Okay, let us look at how uh, how to insert element in linked list. Till now, till previous video, we have covered so many topics like creation and display is the first video that that I have made. After that, again display in normal display, recursive display, count, iterative count, and recursive count, iterative sum, recursive sum are covered in second video, and this is the first this is the third video. Here I'm going to insert an element into linked list, right? First of all, let us know how the logic works. See, I have a linked list, so let me take a linked list and let it be like it has four values. Let me give four values. Okay, so now it has a 2, like 2, 3, 10, and again 4. So as I said in the first video itself, I said while creating the first node is different from creating all other nodes. So all other node can be created in a single method. First node has to be created in separate method, and we have done that. Similarly, for insertion and even for deletion, which I am going to cover in next video, uh, even that should be done differently for first and remaining all other elements. First method, let us see how we can insert element at the first, right? At first of all, it is so much easy now to know how we are going to add any node, right? First of all, we need to create the node. So I will create a new node using malloc function in C or new function in C++. I'm going to fill with some value, I don't know, whatever the user gives. Imagine he gives like 19. Okay, 19. Then the first is here, right? First is here, and normally all are connected like this. So this is how we know how singly linked list looks like. This is a null. It is pointing to the null node, we can say. So this should be pointing here, right? So imagine this is a T. This is a node that we created. So T next should be first, right? It's so much logical. T next should be first. So I connected. Now I'm going to make this first as T. Means I'm going to make first, let it point at T itself. So this is how it looks. So it is so much easy now, right? Adding at the first place, it is so much easy. I just you know what I did, right? I created a node. I pointed to the first node using T next is equal to first. After that, I pointed first onto the T itself. So it is same. It is looking like a linked list, right? That is how we do. Not it is so much easy to add at the first, but let me add at imagine we don't have this part. Again, we have normal linked list that we created, and we don't have the line, this line. Okay, now if you consider indexing, how would you give the index? Like 0, 1, 2, 3. So in the function, what I am going to do is, if I am going to send 0, index 0, at index 0 you need to add an element, then it should be added at the first. That is how I consider. At 0th element I am going to add the new node. What if I need to add at index 2, right? Let me clear this one. Okay, I need to add at index 2, right? So here is our pointer. Imagine we need to clear this node which is at index 2. Actually this index is just our reference. So what I do is I will take a pointer. Initially I will take a pointer. Imagine that pointer is pointing at first initial. Let me call it as a P. I will send this P to the next node. So P will be pointing here. So why I am going to take the pointer at first, if you ask me? Because see, the only thing that we know about this linked list is the first pointer, the pointer that is first, right? The first pointer will be pointing at the first node, so it is only our reference to get to the other nodes. So we can't get directly to any other nodes. We don't have that address. So first I'm going to place the pointer P at this node. Okay, right? Then I am going to push this P to the next node. So imagine we don't have P here. It is at the next node. Now what I do is I will make P next, right? First of all, before doing this, I should have created a node. I have created a node with some data of my wish or user wish, then a pointer, like null pointer, right? I should have created this one. Okay, then what I do is P next is there now. P next should be equal to this next. So we have P, right? P. Okay. So what I said is you should get what in a single simple term. What you should imagine is you should get to the position just before the index where you need to add. Like at 2 you need to add node, right? Just before that node you need to get into that position. That is what I am trying to tell you. After that, I have created a node here. Let me take it as a T, right? T node will have a data and a pointer, and this T next should be P next, right? P is at index 1, so T next should be at T next should be at P next. After that, what I am going to do is I have created a I got to know the index where I need to add, right? Then what I do is P next should be pointing to the T. So it is so much logical. So what I do is P next should be pointing to the T. Here P is nothing but 1. So what I did is imagine P let me draw here. P is, again let me explain you once again, using the first pointer first, which is called as first, which I have taken in the code. I have taken a P here. After that I push to the location just before the index I need to add. Then P is pointing to this node. Then I have taken a T, which I created a memory in heap for both data and pointer. And this P next should be equal to T next. P next I have already given. Imagine this line as a P next, and I have given to T next. After that I will cut this pointer. I will cut this P next, and I will make this P next equal to T, right? T will have this node. So I have just literally joined this node here between these two things. So the index will become 0, 1, 2, and this will be 3, and this will be 4. So this is how it works. So let me write the code for that. I am going to write a function call. Let me call it as a insert, insert, insert. Let me take I as capital. So I will send first, because only thing I know about this linked list is the first node. Okay, after that I'm just doing some changes. I don't need to return anything. Nsert insert. Again I'm taking the some local pointer which is of node type, which is equal to the first, right, first pointer. Then again I forgot that we should send the index, right? Index we need to send. Imagine I would send 0 as an index. That means at first point I'm going to add the node. After that I need to send the data. I need to, like, I will send 100. This data has to be placed at the first of the uh, linked list. So this is how I am sending. So while receiving, int index, then int some key value, let me call it as a key. So after that, if what I am doing is, if this index is equal to 0, if it is the first node that you need to add that element, at first position you need to add, then you need to make, first of all you make a node of you create a pointer of node type. Let me call it as a t, which I did in the diagram. Let me make t is equal to new node. That means I have created some memory in heap for both data and pointer. Let me take t data, let it be equal to the key value, right? Key, I have done. So here what I do is t next, right? T next will be pointing to the first, then first will be pointing to t, right, as I already explained. And then else, if it is not the first element, first position that you need to add, what should you do? At that time you run a for loop. I is like, you need to bring till the index before that, right? If you are placing at node 2, then just before that you need to bring the pointer. For that, index I is equal to 0, I less than, like, n minus 1. N minus 1 means here index just before, that means index minus 1. That is where I need to bring I plus plus I do. So I will push the our pointer which is there at head initially. Will see for our example I will take this and I will show how it works. For our example, what we need to do is, I will just paste this here. So we have, let me make it bigger. So we have this one. Initially I is equal to 0, right? I is equal to 0. Then I is less than index minus 1. For us index is 2. So index is 2, right? Index is 2. Index minus 1 is 1. So if I is less than 1, you need to push. Initially p is at first. If 0 is less than 1, you push. So if I push p to the front, then p will be pointing here, right? P will be pointing here. After that I will increment I, it will be 1. 1 is less than 1, this is a false, so it will break. So I will get this position just before the index. That is how it works. Okay, then I got to the just position before the before the index. Then what I do is p actually t, right? T is the node I have created. T next will be equal to p next, right? P next, then p next will be equal to t itself. Just write it how it works. Just we saw how it works. P next will be nothing but t, and sorry, t next will be nothing but p next, then p next will be nothing but t, that we have explained now. So t next will be p next and p next will be equal to t. So it is right, I think. So let us pass this one. Let us see. Let me display again. I will take this normal display function. I will again call. Then if I run, let me give like 6, 1, 2, 3, 4, 5, 6. So we are getting 100 at the first position. So great. Now let us do the second position, right? It should be at the index 2. That means it should be 100 should be at the third place, not the third index, third place. 5, 1, 2, 3, 4, 5. So we are getting at the third place. That means second index we are getting. So this is how insertion takes inserting of the node will takes place. Next video I am going to discuss about deletion.